How many of you have converted binary to decimal, decimal to binary before? Aaron, Caitlin, Sue, Jordan, you have?
Not by hand.
Huh?
Not by hand, but
Okay. You're going to have to be able to do that successfully to survive this lesson, but I'll teach you if you don't know how to do it already. So we're going to try to figure out how the Internet Protocol works. What do we use the Internet Protocol for? Communication between computers, yes. Specifically, well, first of all, what layer is IP used? Not TCP, but IP. Austin?
Internet protocol would be used on layer 3.
Layer 3, network protocol, or network layer, okay? So we use Internet Protocol to function at layer 3 of the OSI model. So what is that telling you? What's layer 3 all about? We just covered this last chapter, yes?
Networking.
Brilliant. So you're not only tardy, but you're brilliant besides. What do we use layer 3 for? Come on. Go back to your notes if you have to. Austin.
For communication.
Communication between computers. What do we use layer 3 for? Michael. Routing between networks. So that tells you that the importance of the Internet Protocol, which is what we're going to talk about, which is the primary protocol that we're concerned about at layer 3, is used to move packets between networks. So give me a definition, or give me an example of a network address. Give me an example of a network address using the IP or Internet Protocol. Austin. Owl. Give me an example of an IP address. 168.255.10.5. That's an example of an IP address. And within that IP address, we have two components. What are they? Jason? Within that IP address, we have two components. Taylor? Not within the IP address. That's at the physical layer, or at the data link layer, I'm sorry. Within every IP address, we have two components. Yes? No? Yes? We have the network address and the host address. Okay? I'm trying to get you, we've already covered this material. You sure already know that. Okay? All right. Before we get too much deeper, these are the objectives or the skills on the left-hand side and the description on the right-hand side. Understand IP version 4, understand IP version 6. We'll know more about IP version 4 than we will about 6. 6 isn't even used on a regular basis anymore. If you can get by with IP version 4, you should be all right. Okay? On the test, on the certification test, I'll give you enough information, you'll be able to pass the certification test on IP version 6. And you'll also understand why IP6 is why we're going to need it eventually. Okay, we use the TCP/IP communications protocol suite most often. Other options for communication suites are, or protocols are NetBUI, IPX, SPX. None of those are really used on a regular basis anymore. But we use TCP/IP. Within the TCP/IP suite, there are multiple protocols built into that. Most obviously, TCP is part of it, and IP is part of it. What is TCP used for? Again, we just covered this in an earlier chapter, yes?
Sending files somewhere, and you would get a confirmation back.
You get a confirmation, so connection-oriented communication. So the TCP protocol, Transmission Control Protocol, the TCP protocol is used to guarantee communication between two devices or multiple devices. Okay? The IP part of the TCP/IP suite. It's what we use to get packets from one what to another. What? Yes. Not one host, because we can use TCP within. We can use TCP to do that. IP is used to transmit packets between, yes,
Different networks.
different networks. Different networks. That's the most important thing you can remember in this chapter. IP is used to transmit packets between networks. All right, as the example that Austin gave us of an IP address, the top one, actually all four of those are listed as good examples of IP addresses. Okay? All of these addresses can be used in a network. When we say the numbers are between 0 and 255, we're talking about what type of numbers? What type of numbers? What is a number like 208? What is that a representation of? What format is that number? Anyone know? Yes?
So, do you need just one section or the whole entire?
Now, what is the 208? I'm looking for a name. Yes? It is decimal, right? Decimal format. Okay? It is in decimal format. It is in decimal format. Okay? Now, when we combine decimal format into four numbers, like we've got 208 dot 32 dot 56 dot 232, it's not point. Don't ever say point in my class or among other IT professionals. You'll immediately be found out as a fraud. Okay? 208.32.56.232 is decimal, yes, but between it we have dots, so we call it dotted decimal format. Know that. Etch it in your hearts forever. Dotted decimal format is what you're seeing there. Okay? Each one of those four decimal numbers represents something. What is it called? Each of those decimal numbers represent. Let's back up. Let's back up. How does a computer communicate with another computer? What format do the electrical signals, if we're using say a UTP connection, what formats are we sending? Does anybody know this? On and off, on and off, on and off, on, off, off. Zach?
Ones and zeros?
Ones and zeros, okay? Ones and zeros, if we only have two options, ones and zeros, and then all the combinations of those ones and zeros, what numeric format is that called? Yes?
Binary.
Binary format, okay? That's how a basic computer communicates. That's how signals are sent across the wire or the fiber or the wireless connection in ones and zeros. That's its most basic format. You look at these packets, the packets are made up of ones and zeros. Okay? When we are addressing a packet, because every packet, when I'm sending it between, when I send a packet between networks, every packet has two things so that it can get there and then it can get back. What are those two things called? If you look at the header of a packet, there are two sets of numbers that are included in that header. What are those called? When we look at the packets, they are in decimal format. Okay? So you'll see 208.32.56.232 and maybe 12.5.24.2. What are those called? Yes?
Would it be an IP address and a MAC address?
Would it be what?
An IP address and a MAC address?
Nope. They are both IP addresses when we look at them. But in the header, yes?
The destination and where they came from.
Destination, and another name for where they came from that we talk about is source. So there's a source address and a destination address, and that's in the header of every packet. And then in addition to the header, we have the body of the packet, and then encryption stuff and all that. But the most important thing for this chapter is every packet has a destination, and if it's going between networks, that destination is always on a different network than the source, where it came from. Okay, so it knows how to get back to that packet. And so in between this packet and that packet are a bunch of different things that we call what? There are smart devices that can guide them, give them a roadmap to where to get to this source to this destination. What are those things called? Miguel, what are the electronic devices in between two networks called? They move packets between two different networks. They are the building block of a wide area network. They're not a switch, but a what? Not a hub. Austin, don't tell them that. I'm not giving up. Huh? Another electronic device. What do you have in your house? Do you have a wireless access point in your house? Okay, what else is it doing? It's also, you guys normally refer to it as a what? A router. If I'm moving packets between two networks, I must have a router, right? Because the router knows what network addresses are on this side and what network addresses are on this side, and so it knows where to move them. Okay? So, we look at a packet, it's got a source address and a destination address. The source address is going to be on a different network than the destination address. And as we've said, each IP address includes both the network address and the host address. What's the host address?
The host address?
What is it? What's it describe? What's it the address of? Give me an example. Give me an example of a host.
A computer.
Give me another example of a host.
A phone.
Okay, another example. Keep going.
A TV that has a wireless host.
TV, a smart TV has a host address. Okay? The TV that's in your house has a host address that is different in what way than the TV that's in my house. If you look at the IP address of the TV that's in your house and the TV that's in my house, what are the differences? Yes?
They're going to be different, like, IP addresses.
Different IP address for sure, because you must have unique IP address, but in addition to that, Austin, were you?
Different, the network section of it.
Different network address, okay? All right, so keep all this in mind right now. I'm building to something here to help you to understand how an IP address is actually formed, and then also how it's routed. Okay, in order for an IP address to function, there must be a properly configured IP address and, I don't like that word, compatible subnet mask. In order for an IP address to function, it also needs a subnet mask to tell you something. Gabe, what is that? You know? We've talked about it before. What are the two components of an IP address that we just talked about? Host address and what else? Not the MAC address. We already determined that's not it. Seth, what are the two components of an IP address?
Host address and the destination.
No, that's part of the header. Jessica, there are two components to every IP address. One is the host address. The other is what? No. Yes. The network address. One more time. Everybody write this down if you haven't done it already. There are two components to every IP address. Network address and the host address. The subnet mask tells you what, an IP address always is in dotted decimal format. 208.5.17.34. Okay? Every one of them is in dotted decimal format. They look the same. They look similar, right? 4 components, or 4 decimal sections separated by dots. God bless you. The subnet mask that's associated with that IP address tells you which part of that 208 dot whatever it is, 208.32.56.230, it tells you which part of that IP address is the network, tells you what the network address is, and it tells you what the host address is. Okay? If I had, and I'll give you, can anyone give me an example of a subnet mask? Caitlin. 255.255.0.0. Okay? I don't think that's what he said, but close. All right. 255.255.0.0. If that is the subnet mask that you're using on the network with 208.32.56.232, Aaron, what is the network address for that IP address? Huh? It's the first IP address up there with the subnet mask that Caitlin gave us, which is 255.255.0.0, otherwise known as a 16-bit subnet mask. What is the network address? Nope. Well, that's what it tells us. Q, do you know the answer?
Is it 2A.32.0.0?
You mumbled at the end.
.0.0.
That is it. The network address, if you have a subnet mask at 255.255.0.0, the network address for that IP address is 208.32.0.0. That is its network. That is its network. It's never going to change. It's not going to, you cannot find it someplace else. It is unique. That network is unique. Yes?
Can you repeat that again?
We're going to get into a lot of detail. I'm just hoping you guys can first identify some patterns. Okay, so just kind of hang with me. You don't have to write all this stuff down. Just try to identify some patterns. That's where I'm going with this. Okay, if the subnet mask that we assign to that IP address, now, by the way, you control this. You're a network administrator. That IP address happens to be a public IP address, but if you use it inside your network, you can make it anything you want. Your only rules are, if you want hold on, Austin. If you want computers within your network to talk to each other, then they must have the same network address, unless you have a router between them, but let's just say in a local area network. If those computers are to talk to each other, they must have the same network address, and then they must have different something. What is that? Austin.
They have to have different host addresses.
Host addresses within that network. Okay, I gave this example once before, I'll give you the example again. If my home phone number is 574-935-3882, what part of that could be compared to the network address that we use in IP addresses? Yes? The 574, okay? Because there could very easily be in Chicago. Okay, well, let's back up. So within the 574 area code, everyone in here is within that 574 area code, most likely, maybe some 219s, but I doubt it. Okay, in the 574 area code, can anyone else in our current public exchange telephone system have the phone number 935-3882 and be able to function? No. The phone company requires us to all have unique phone numbers within that 574 area code. However, within the 312 area code, which is Chicago area, absolutely, someone could have the phone number or host address in our comparison of 935-3882. Can the phone number 312-935-3882 call the phone number 574-935-3882? Right? Somewhere there's a telephone equivalent of a router between them that knows, well, if I want to contact 935-3882 with a network address of 574, then I need to send it to this router who knows where the 574 area code is, so it's going to send it to this router, it's going to send it to this router, it's eventually going to go to my phone. That's how routers in the TCP/IP network work. In our example up here, 208.32.56.232, you as a network administrator assign the subnet mask that's associated with that IP address. You could, if it were a private network like this room, if it's a private network in this room, you could make that subnet mask 255.0.0.0. You could make it 255.255.0.0. You can make it 255.255.255.0. You can make it 255.255.255.128. Those are all separate network, or all separate subnets that change on that exact same IP address, that change the network address. If the subnet mask is 255.0.0.0, what is the network address of that first IP address? Zach. Caitlin. Take a break.
Rocks. How was that free pizza sauce for you? Cheese sauce.
I was just doing it in a recap.
My ears been ringing, so sound like it's going
I did it first, but it's been going on.
There is a reason we'll talk about it. It's the rules that are associated with how it defines the network versus the host.
Either stand your seat or go to the home. You don't need to be over here. You don't need to be over here.
No, there's a logic to it. Yes, sir.
Why are you?
Well, that's how you assign it.
Dustin?
Go to your seat.
Yeah, I've got some great ideas. Did you ride with anybody? Okay.
It's like a
So,
strategy defense game. You can take a look and it's like
What are you junior senior?
other colors and your weapons make 7 meters per second.
Okay, let's look at these standards.
Or less.
Now, how about the height?
AURUX.
Well, I think it'll look like. Okay, so there's your goal, right? There's your end in mind. There are two ways to achieve those 3Gs, the R's. One is you just meet those requirements. The second way is you can take out. So in other words,
Stars.
He can't go in.
You're still going to get because even though you weigh 300 pounds, or like a 12 weight, you're going to take that's
She was like, we didn't have to use this body. Like, why don't we use I said that.
First, I didn't know she's a higher grade.
She's not even a teacher, dude. She's responsibility.
Yeah, man.
So my body fat percentage is way under range. So I always struggle.
And then she was like, plus. And then she pointed and said, yeah, you need this done. I was like, what are you doing? Like, there ain't things like, I was like, why are you coming out to me? I'm not the worst. She's like, don't have that.
Mine's just